Hello and welcome to the Enterprise Manager Cloud Control demo series. Today we are going to focus on cloud management. More specifically, talk about using Cloud Self-Service Portal. We will see functionality to allow cloud self-service users to create new platform deployment requests through the portal, manage requested deployments, track metering and chargeback information, author and enforce cloud policies. So let's get started. Enterprise Manager Cloud Control provides a self-service portal which can be used by business users or cloud consumers to request cloud resources. Here I'm logging in as John Smith, who is an application developer and wants to request some WebLogic environments. On the left-hand side, John Smith can see his quota. He can see that he can request up to 50 servers, out of which he's requested 4 already. He can request up to 100 CPUs, and he has requested 8 already. The portal also allows John Smith to look at some of the notifications that the administrator might have sent. For example, here he says that some of the new software assemblies are published for the self-service user to consume. John Smith can also visualize all the servers that he has requested so far, and he can also look at all the requests he's made through the portal so far. Let's go ahead and create a new request for a platform deployment. As you can see, self-service users can only provision in a specific zone in the cloud that they have access to. This allows administrators to control who can deploy where in the cloud. These zones could be tied to a certain cost center or to a certain business unit, thus enabling the administrators to charge back the usage of resources in the cloud to a specific cost center. Let's go ahead and pick an assembly or a cloud service that John Smith wants to deploy. Here you can browse the published assemblies from the Enterprise Manager software library and use that to deploy the platform. I would give some name for my deployment instance, a web shop dev instance, which would basically be a deployment of web shop assembly. As you can see here, this web shop assembly essentially contains 4 different appliances. It has a database appliance and 3 WebLogic appliances: the WebLogic admin server, WebLogic cluster, and a separate WebLogic managed server. Assembly designers can decide to create these appliances and these assemblies as per the best practices that they want to enforce. Here you can see that the assembly designer has chosen to allow the cluster tier to only scale up to 2 nodes and a minimum of 1 node. Let's go ahead and configure a specific tier. Here you can see a WebLogic admin server tier. John Smith can choose to request a certain kind of machine for this tier. Here I'm requesting a 1 gig machine with 2 CPUs for the WebLogic admin server. We can define a custom size. Administrators can choose to only allow predefined sizes for the machines that users can request, like small, medium, or large machines. The user can also specify a VNC password with which they can log into the machine once the request is complete. They can also choose to specify additional network cards or additional storage for the machines that they are requesting. One of the big value adds that Oracle provides is product configuration. Not only Enterprise Manager provides automation for provisioning virtual machines through the portal, but it also allows for configuration of the software within the virtual machine. So here, as part of the platform as a service solution, you can see that WebLogic configuration parameters that are available in the WebLogic assembly are exposed here. John Smith can choose to override the values of the parameters that are allowed to be overridden by the assembly designer. This is a good mechanism for assembly designers or administrators to expose different kind of cloud services to different kind of users. For example, for less sophisticated users, they can choose to default all the best practice configuration, whereas for sophisticated self-service users, they can choose to expose these values and allow the user to override these values as per their requirements for their deployment. Let's go ahead and schedule this deployment. Resources in the portal can be requested for immediate use or for future time. For example, a tester might request some resources for next week when they want to start testing. Let's review the request and submit. This creates a new request for a platform deployment. Let's go ahead and see some of the deployments that have already been made. Users can see their specific assembly deployment and the different tiers within that assembly deployment. They can also see the machines that constitute that tier. Let's drill down into one of the machines that the user has requested. Enterprise Manager self-service portal allows the user to view and manage some of the deployments that they've requested. They can see the monitoring metrics for performance management of their machines. They can also see some configuration for their machines. They can take certain actions such as starting, stopping the machines, or launching a VNC console to access the machines. This empowers the users and makes them take actions in a self-service manner without going through the administrator for every small need. We can now drill down into a specific tier and see that the portal allows certain actions at the tier level. For example, you could choose to scale up or manually scale down a tier if you want more resources or more capacity for your deployment. The portal also allows requests for storage. So at a later time, if the user needs additional storage for their deployments, they can choose to make additional requests. Users can also track metering and chargeback information. They can see how much they're consuming in terms of IT resources, in terms of physical resources for CPU, memory, storage, etc. They can see here how much they're paying for what they're using. Based on the charge plans that are defined by the administrator earlier on during the self-service setup, users are charged as per that plan. Here you can see that this user, John Smith, is being charged 10 cents per CPU per hour, and here you can see the aggregate usage and the total charge. Similarly, they can filter their charge by a certain performance metric or certain resource. So for CPU, they can see how much they're paying for it. Let's go ahead and look at the library where the users can store their own deployments. A My Library area allows a user to either upload their own assemblies and templates or save their deployments for future use. They can also share their deployments or their assemblies and templates with other self-service users. Users can also define certain cloud policies. The portal allows two kinds of policies to be defined: schedule-based policies and performance-based policies. Schedule-based policies could be actions that users want to perform on a recurring basis. For example, they might want to shut down their machines at 12 midnight and start them back up at 6 a.m. because they don't want to use or pay for the machines at night when they're not using them. Similar automated schedule-based rules can be defined. Performance-based policies could be workload management policies which take into account performance metrics. Let's go ahead and define a performance-based policy. Here is a scale-up policy that's going to act on a specific tier within an assembly. The policy can use any of the metrics as condition. So here we're going to use the CPU metric, and what this policy says is if average CPU utilization is greater than 90% for 5 occurrences of the metric collection, let's say a collection happens every 5 minutes, then for 25 minutes, if the CPU utilization of a guest within a cluster is more than 90%, then we can choose to take an action like scale up the tier within the assembly. So automatic scale up and scale down allows for a very elastic dynamic deployment which can grow and shrink as per user's requirement. Here we choose to scale up by one node at a time. We review the policy and save the policy. Once the policy is authored, it can be then associated with certain machines or tiers within the assembly. Let's go ahead and create a policy group. A policy group is a collection of two or more policies. So let's go ahead and create an auto-scaling policy group that basically contains a scale down policy and a scale up policy. Let's now go ahead and associate this auto-scaling policy group to a specific tier. This basically allows users to automate the workload management for their resources within the cloud. The portal also allows users to set certain preferences. They can choose to set certain passwords which they don't have to enter again and again when they request deployments. They can also choose to say that all their deployments can go to a certain zone that they have access to. They can also specify an email address if they want to receive notifications. They can receive notification, the first notification few days in advance or a second notification before their resources are going to expire. They can also enable notification based on a quota threshold. So if they're going to reach 80% quota, they might want to be notified through email. Thus, a self-service portal allows a cloud consumer to request resources, manage those resources, see the metering and usage details of those resources, and also set certain cloud policies to manage the workloads and the deployments automatically.